Okay, so I'll start. It's a very important lecture. This is the first time you are going to see some kind of routing protocol. So what we have studied yesterday was different types of issues that we are facing while routing the data from sender node to the receiver node. Now, yesterday we had discussed what is the basics of routing and what is the difference between routing and forwarding. So, from transmitter to receiver, if many paths are available, we are first selecting in our mind that this is one path through which the data will be transferred. So, before the packet forwarding, routing happens. So, routing is just selection in mind that one path through which communication of data packets will take place. Now there were different issues in routing, design issues, and there we had found mobility is one issue, bandwidth constant is one issue, hidden and exposed terminals are one issues, and network energy constant is another issue. So all those things we had discussed yesterday. Features of ideal routing protocol, that also we had discussed yesterday, and what are the difference between routing protocol for ad hoc wireless network and cellular network, which is central control. That explanation also I had given yesterday. So today what we are going to see is, first we are going to see different types of routing protocol. So there are mainly classification. Classification is of four types depending on different criterias that we will see first. And after that we will do two types of routing today, and two very important types of routing. One is called as DSDV, that is called as table based routing. So this was the first initial primitive kind of routing protocol, and second one is Fisheye state routing protocol. So there are a lot of diagrams I have drawn. It took quite a lot of time to draw the diagram. So in exam, if they're asking exactly this kind of diagram, you have to represent, and the same diagram you will get in book, in your book, that is the Manoj and Murthy, and the same diagrams I have written here. So if you are just going through my slides, I think that will be more than sufficient to write 10 marks or 15 marks questions in the exam. So I'll start with the first type. There is a classification of routing protocol. So this classification is not mutually exclusive. That means exactly it's not very distinct classification, that one type of routing protocol is having feature that you may find in some another type of routing protocol also. So some routing protocol, due to their common property, may fall in more than one class. Okay, so one routing protocol may be falling in two different types of classification also. That is possible. So there is a huge table of classification of routing protocols. I'm not showing you that. I'm showing mainly four types of routing protocol, and from there mainly two types are there in our syllabus to study. So it is saying that wireless network routing protocols are different than traditional wired routing protocol. So yesterday we have discussed it. Whenever it is wired network, at that time routing becomes easy, but for wireless network it is difficult, and wireless network with mobility it becomes more difficult. So pathfinding process, so routing is a pathfinding process through which the future data transmission will take place. So this pathfinding process of wireless network is worth more exploration. That means still there is scope for research. Ad hoc wireless network routing protocols are classified mainly into four categories. So first category is based on routing information update mechanism. So yesterday I told you that the routing or path, once it is decided throughout the operation of the network, it is not fixed. Okay, because node is moving. So once the node moves from one place to the other, suddenly the whole routing table, whole routing paths and routing protocol, everything changes. So inside one protocol, you will be finding for same sender and receiver, there might be different paths. So updation of information or updation of table continuously happens inside this routing. So based on the routing information, how it is updated, whether it is updated very fast, whether it is updated very slow, whether the nodes are moving very fast or slow. So whether it is table driven routing or hybrid routing protocol, whether it is reactive or on demand routing protocol. So these are the different types that is actually a part of information based routing. So information can be stored in a table, information can be continuously updated, information can be updated in a hybrid fashion. So what are the different things of information table based routing, we will see in this lecture only. Okay, so this is a part of our syllabus. Next type of routing is using temporal information for routing. So temporal means related to time. Okay, so based on use of temporal or based on time information for routing, so there are two protocols. One is past temporal information, another is future temporal information. So what has happened, depending on that we are classifying routing protocol, and what is expected and what is going to happen, depending on that we can classify the routing protocol. So this is a second type of classification which is based on temporal information, that is time related information for routing. Third type is based on routing topology. There is flat topology routing protocol or hierarchical topology routing protocol. So we'll see types of this, flat or hierarchical. So one hierarchical topology we will see here in today's lecture most probably. Okay, so depending on topology, how the nodes are arranged, whether nodes are very closer to the central area. Central area means wherever the sender node is there, that is called as central area for a topology. And as you are going away from the central area, you are going towards destination. So destination is away from the central area, and sender node from where the source of information is there, that is called a central area for any topology. So depending on the topology, how the nodes are arranged within the area, that routing topology is classified. So there are two types, one is flat routing topology, another is hierarchical routing topology, like that. And fourth type based on utilization of specific resources. So I told you there are mainly three resources. One is energy, another is nodes, another is bandwidth. So power aware, that means this is energy sensitive routing protocol. This is part of our syllabus. And then geographical information assisted routing. So GPS and all those things can be fitted with the nodes. So depending on whatever geographical information nodes are carrying, based on that we can classify the routing protocol. So these are mainly four types. We will be saying this table driven routing next, and then there is reactive routing, then there is hierarchical routing, then this power aware routing. These are part of our syllabus. So now onwards, because I told you last day there are mainly two types in this, there are mainly two topics in this module. First is routing and second one is TCP over ad hoc wireless network. So in routing, these three types of routing we will see, and one topic from each of this classification we will see as per our syllabus. First I'm starting with the cable based routing. In short form it is called as DSDV. So there is routing based on information update mechanism. So continuously there is no mobility, continuously the paths are changing. So if paths are changing, that information is updated in the routing table. Routing tables are exchanged among different sender nodes or sensor nodes, because every sensor node need to have overall network topology data. Then only the routing becomes easy. Then only we can avoid collision. So proactive or table driven routing protocol, it is saying that it is extension of wired routing protocol. So this is the most primitive, most initial type of routing protocol which was being followed in case of wired network. So the same concept we are trying to bring in case of ad hoc wireless network. That's what it is saying, is extension of wired routing protocol. Here every node maintains a topology information in form of a routing table. That means which are the next nodes from here, if the sender is there, if there is at another corner there is a receiver, how many hops are there in between the sender and receiver, how many nodes have to be crossed so that information can be passed from the transmitter to the receiver. All these are topology information. So that is continuously stored and updated in the routing table. So this table are frequently updated to maintain accurate network state information, which is flooded to every node in the network. Flooded means that information is given to all the network nodes continuously. When a node tries to find a path till the destination node, it runs pathfinding algorithm on the topology information. Next, destination sequenced distance vector routing protocol, or this is called as DSDV. So DSDV is one type of proactive or table driven routing. As shown in the previous classification, I have shown three types of table driven. In that case, one is this DSDV. So in DSDV, we are going to study in detail. What we are doing here is, this protocol is the first protocol in ad hoc wireless network. So this is the first routing protocol in ad hoc wireless network. Each node here maintains a table that contains the shortest distance and immediate or next node information from the source to the destination. So first information is what is the source node. From there, if you want to go to the destination, which is the next node of the source node, that is a very important information. So from the sender node, what is the next node for transmission, that information is stored, and this information helps to prevent loops to counter, that means to not to happen. So loop cannot happen in this, to counter the count to infinity problem or fastest coverage from sender to the receiver node. So whenever we are determining what is the sender node, just after that what is the next node to the sender node where data will be transmitted, that is very important information. Plus from source to the destination, how many hops, how many intermediate nodes. So intermediate nodes are also called as routing nodes. So how many hop counts are there, that means how many jump data has to take, or how many intermediate nodes are there. So all these informations are continuously updated or tabulated in this kind of routing protocol. Here, it is an extension of Bellman-Ford algorithm. So you no need to understand this, but Bellman-Ford algorithm is something like this. There also, this hop count, next node information, all these things are continuously captured. Each node maintains a table. Routes to all destinations are readily available at every node at all times. So every node can be a sender node, every node can be a receiver node. So if you are posing that node as a sender node, then for any receiver node, what are the intermediate nodes, how many hops counts are there, how many what might be the energy information. So all these things can be continuously captured in table form and updated. Okay, so there's a very primitive initial kind of a routing which is actually in the shadow of Bellman-Ford algorithm. So the tables are exchanged between neighbors, that means neighbor nodes, at regular intervals to keep an up-to-date view of the network topology. So continuously the tables are updated regarding the hop information, link information, intermediate node information, and those information tables are exchanged between one node with the surrounding nodes. So this is actually called as DSDV type of protocol. The tables are also forwarded to if a node observes a significant change in local topology. So due to mobility, suddenly the whole topology of the network might change. So if there is a change, then the tables are updated, and tables are updated in two types. So one is incremental update, that means one by one stepwise updation. So one link is updated, depending on the next link is updated, depending on that next link is updated likewise. So there are two types of table updation. One is called as incremental updation, another is called full dump. So full dump means, so incremental updation means step by step. So one node has shown some mobility, depending on that one link is updated. If that link is updated, that is forwarded next, that is forwarded next. So one link at a time, one node at a time updation happens. That is called as incremental update. So in incremental update, it takes a single network data packet unit, which is also called as NDPU. In incremental update takes a single network data packet unit, while the full dump may take multiple NDPUs at one time frame. So there may happen changes. So if the changes are happening individually, gradually, one link, one node at a step, one step at a time, then it is called as incremental updation. So the whole network is updating its surrounding hop count, link, and intermediate node data. If it is incrementally happening one node at a time, then it is called incremental update. And if it is happening, the whole network topology is changed, and in one shot the whole network topology is being updated. In that case, it is called as full dump. So it is suppose somebody is renovating his home work, so his home actually. So in at home there are suppose 4 rooms. So one room you are renovating, and after 6 months again you are renovating one room, after 6 months again you are renovating one room. So this is called as incremental type of renovation. So one room at a time, one link at a time. But at the same time, if the whole building or whole home is being renovated, that might be called as full dump. So it is all about updation. If it is happening in step by step, it is called as incremental update. If all the network topology is updated in one shot, it is called as full dump. So it is all about data exchange. Obviously, incremental updating is slow, and full dump type of update is very fast. Now this is a diagram. You have to remember this diagram will keep on coming for next coming some 10-15 slides are there. This diagram will keep on coming. You have to understand. So there are total 15 nodes. This is called topology graph of the network. So here node 1 is the source node and node 15 is the destination node. Not necessarily you will have to take 1 as the sender and 15 as the receiver. Somebody wants to take 3 as the sender and 11 as the receiver. That also will do. And in exam what I ask you, don't draw such a big diagram. Okay, so you can take a network topology of 6 to 7 nodes and you can show your whole topology and you can explain this DSDV table. That is not a problem. Okay, so in this case, one is the sender node and 15 is the receiver node, and all the 15 nodes are capable of maintaining global topology information. That means there is memory in every node. Okay, in all these 15 nodes there is memory information or memory hardware. So this data tables, what is table, what is stored in the table, I'll show you shortly. So the tables of network information can be stored in every node, and that is possible. So the route is already available. Routing table of node 1 indicates the shortest route from node 1 to destination 15. So if I am saying I am first supposed to design a route table for node 1 as source node and node 15 as destination node. So what will be the route table? So just see the path. Okay, the path can be like this. So from 1 the data will go first to node 4, then from there it will go to node, sorry, first 1 it will go to node 5, then it will go to 4, and then it will go to 12, then it will go to 15. So this is one path. Okay, so here node 1 is the source node and node 15 is the destination node. All 15 nodes are capable of maintaining global topology. The route diagram is given here. Now what we are finding is this routing table of 1 indicates shortest route from the source to the destination. And what are the intermediate nodes? 5, 4 and 12. They are the intermediate nodes. So this information is stored in the routing table. That is 1, 5, 4, 12, 15. So this path is stored in the routing table. Secondly, how many hops? So this is one hop, single hop, 2 hops, 3 hops and 4 hops. So that's why it is written node 1 to node 4, hop node 1 to node 15, there are 4 hops. So node 1 is 4 hop distance to node 15. So these two information, so 4 informations we can find from here. First is what is the source node? Source node is 1. Second is what is the destination node? Destination node is 15. How many hops are there? There are 4 hops. And how many intermediate nodes are there and which are they? So intermediate nodes are also called as routing nodes. So 5, 4 and 12, they are the intermediate nodes. Now the question is there only one path? Is there only one route? The answer is no. Just check the same topology. Here 1 is the source node, 15 is the destination node. In this case, you will find there is another path proposed. So just immediate sensor node to 1 is 5. Okay. Just after 1 information is sent to 5, then previously it was going to 4, now it has changed its route. So now it is going to 10, then 12 and then 15. So this is another path. So 1 to 5 to 10 to 12 to 15. So this is another route. So the same thing is written here. Routing table of node 1 indicates the shortest route to destination node 15 through the routing nodes. Now it is previously it was 5, 4, 12. Now it is 5, 10, 12 and 15. So node 1 is 4 hop distance to node 15. So previously 5, 4, 12, 15 it was 4 hop. Now 5, 10, 12, 15. Now it is also 4 hop, and it is more or less each hop is having same length distance. More or less it is taken same. Okay. So this is the routing information. So here also 4 information I am saving. First is source node is 1, sender node is 1, destination node is node number 15. And 5 is the immediate node, 5, 10, 12 are the intermediate nodes, and there are 4 hops that is there from sender node 1 to destination node 15. So this 5, 6 informations are continuously updated in table. Let there be any source node, let there be any destination node. So this 1 is the source node and 8 can be destination node, possible. Okay, so here I am doing end to end, so that is 1 and 15, not necessary. 1 can be the source node, 2 can be the destination node, that is also possible. So if 1 is source and 2 is destination, it is 1 hop distance. Next node is 2, okay, and it is only having 1, there is no intermediate node between 1 and 2. Okay, so those informations are continuously stored. So this graph, whatever is shown, it is called as topology graph of the network. See another case, if 11 is the destination node, so instead of 15, now 11. So this green color I have kept as a destination, yellow color I have kept as the source node, and intermediate nodes are given by red. So previous case also you check 5, 10, 12, there are intermediate nodes, they were by red. Here also 6 and 10, they are intermediate nodes, they are given by red. So what are the node information? 5 information I am storing. First is sender node is 1. Second information is receiver node is 11. So these are node numbers, node IDs. What is the third information? Third information is who are the intermediate nodes. So 6 and 10 are the intermediate node. This is the third information. Fourth information is which is the next node to the sender node. So sender node is 1, next node number is 6. So what is the next node to the sender node is a very important information. So 6 is the next node. This is the fourth information. Fifth information is how many hops. So this is 1, 2 and 3 hops. Okay, all these informations are required because this 11 might move some other place, because every node in this network can have mobility. So this 11 suddenly might move some other place. In that case also, the whole network topology will change. We have to find out what will be the new network path in that case. So in this case, it is written routing table of node 1 indicates shortest route to the destination from sensor node 1 or sender node 1 to receiver node 11. In this case, routing node 6 and 10 are the intermediate nodes or routing nodes 6 and 10, and node 1 is 3 hop distance from node 11. So this node 1 is 3 hop distance from node 11. Now how all these informations are stored in a table format, that is shown here. So just what is the table? So here I am making that source node is 1. So here what is the destination node, what is the next node to the sender node, and what is the hop distance. Sequence number is an arbitrary number, so this is not calculated. Any number you can give here. So mainly first 3 columns are very important. So let's say about node 12. Okay, so when node 1 is the source node, and node 1 is the source node and node 12 is the destination node. Check here. So node 12 is the destination node. So if one wants to send data to 12, what will be the path? Path will be from 1 to 5. So just see this pink arrow, from 1 to 5 to 10, and from 10 it should go to 12. Okay, so 1 wants to send information to node 12. So 12 is the receiver node now. So I have written node 12 is the destination node, and this is called as topology graph of the network. So if you are asked DSDV protocol, you have to draw this topology graph, as well as you have to draw this table, and for a certain source and destination node you have to show all these things. That what is the destination node is 12. What is the next node to the source node? So 1 is sending first information to 5. Okay, that sets the direction in which direction the flow is going to happen. So 1 is sending next information to 5, so 5 is the next node. Then between 1 to 12, how many hops are there? So from 1 it goes to 5, 5 to 10, and 10 to 12. So there are 3 hops. From 1 to 12 there are 3 hops. And this is a 190, so this is the sequence number. It is not very important, some arbitrary number you can assign. Okay, so this is a very important thing. Same thing, this is I have already shown you. So now instead of 12, I am saying that node 11 is the destination node. If node 11 is the destination node, just check here. So destination node is 11. Next node to 1. So if 1 wants to send data to 11, what is the next node? So previously for 12, next node was 5. Now for 11, the next node will be 6. So next node is 6. Then 1, 6, 10, and 13. How many hops? 1 to 6, 1 hop. 6 to 10, another hop. 10 to 11, another hop. So there are mainly 3 hops, and this is number 176. So this is any number. Okay, so this is the path number, it is decided. So main information is this 3. That sender node is 1, it is said here. Receiver node is 11. Just after 1, next node will be 6, and between 1 to 11 there will be 3 hops, 1 to 6, 6 to 10, and 10 to 11. So this is actually gone to the next topic, that is called as route maintenance. Okay. What is meant by route maintenance? So this is DSDV table we have seen for node 12 as a destination node. Now for node 11, this is the routing table. Now just imagine that this 11 suppose is moving. So this is the same topology shown in a bigger way. What is happening is this 11th node, previously it was here, now suppose it is moving upward. Then what is the problem? Okay, then also the route has to be there, then also the data exchange has to happen between sender node 1 to the receiver node, but in that case the whole route table will change. So that is actually called as route updation. So whenever DSDV is asked, first you have to show for one sender and one receiver what is the table, and then you have to show how the table is updated. So what is written here, the destination node 11 has now moved to a newer location. So it is still moving, it will be following this path and it will end up here. I will show in the next slide. Destination node 11 has moved to a newer location, so routing table will be updated. So node mobility will affect the routing table and updation of routing table will happen. So exactly what is happening? So node 11 previously was here. Now due to node mobility, node 11 has gone up. So previously 14 and 11 was combining, so 11 was here, so 14 to 11 there was a connect, 11 to 10 there was a connect. Now this 10 to 11 connect is gone. Okay, now 14 to 11 connect is there. So this 11 is the newer position of node 11. So this green is newer position of node 11. Now 1 wants to send data to 11. So previously what was the path? Previously 1 to 6, 6 to 10, 10 to 11. So there were 3 hops, and immediately after 1, next node was node 6. Now the whole thing will change. Now just see what's happening. From 1 it will go to 5, from 5 it will go to 10, 10 will go to 14, and 14 it will go to 11. So what are the routing nodes now? Routing nodes are apart from sender. So sender is 1, 11 is the destination. Routing nodes are 5, 10 and 14. So that's written here. Routing nodes are now 5, 10 and 14. So previously it was 1, 6, 10, 11. Now it is 1, 5, 10, 14 and 11. Previously there were 3 hops. Now there are 4 hops. Previously next node was 6. Now next node is 5. So all those things are shown here. So this is the newer position. So this is a newer destination position of node 11. So routing nodes are now 14, 10 and 5. Previously the routing node was 6 and 10. Now the new routing node are 5, 10, 14, and it is sending the data to 11. So just check, previously this was 176. Now a new path number we have given 180. So sender node is same, that is 1. Receiver node is same 11, but the position of 11 has now changed. So what is the next node to 1? Previously it was 6, now it has become 5. So this is the updation. Previously between 1 to 11 there were 3 hops. Now between 1 to 11 there are 4 hops. So previously this table was 11, 6, then 3, then 176. So previously this table was 11, 6, then 3, then 176. Now the table is 11, 5, 4 and 180. So that's why this is called updated routing table for node 1. Okay, so this is what is called as route maintenance. That means even if there is a mobility, even if the node position has changed, but then also data must be transmitted from the source to the destination. So source and destination node remains same, 1 and 11. Previously it was having 3 hop, now it is having 4 hop, and it is sending the data to the same destination. Sir, so advantages and limitation of DSDV. So there are a few advantages and few limitations we will see. So what is the advantages? First advantage is route always available from all nodes to all destination. So I told you before that each node can act as a source, each node can act as a destination. Much less delay is involved in the route setup process. So we have seen in the previous case. So 11 was in one place, 11 has just changed, moved in some other direction, but then also the node breakage is not there. So very fast the rerouting process or route maintenance process happened, and from the same source node to the same destination node we could send the information without any hassles. So less delay is involved in the route setup. The mechanism of incremental node path update makes this existing wired network protocols adaptable to ad hoc wireless network, also with least modification. So whatever were the rules of this DSDV in case of wired network, without much change, without much modification, the same protocol can be used for wireless network as well. Okay, so this is an established network. It is a very well-known network protocol. So not much change is required in case of DSDV when we are changing from wired protocol to wireless protocol. And the last advantage is the updates are propagated throughout the network in order to maintain an up-to-date view of the network topology at all nodes. So whatever update has happened, so previously this was the case, previously 11.6.3 between node 1 to 11. Now after movement of node 11, it has now happened 11.5.4. Okay, so previously the table number was 176, now the table number is 180. So this update is very fast, updated to all the network topologies. So all the other nodes in the network comes to know that between 10 and 11 there is no link now. So if you want to reach to node 11, So previously everybody comes to know that between 10 and 11 there is no path because 11 has moved. Now if you want to reach 11, you have to reach through the node 14. So this information goes to everybody in the network. So these updates are propagated throughout the network in order to maintain an up-to-date view of the network topology at all the nodes. So these are the advantages of DSDV protocol, that is table-based routing protocol. It is the first type of protocol where tables of updation are maintained and they are shared with all the nodes so that all nodes also get updated with the mobility and changes and any other kind of disruption within the network topology. Limitations of DSDV protocol, very important. So the updates due to broken links lead to a heavy control overhead during high mobility. So again, tell you that there is RTS, CTS, data acknowledgement, DS, all those packet exchanges are taking place. So if there is node mobility, so initially RTS, CTS, all these things were exchanged. Now again, when the node moves to a new location, again this RTS, CTS, data acknowledgement, all these exchanges has to take place. So for every change, there is huge amount of control packet, greater amount of control packet generation and exchange that takes place. Okay, and that actually increases the control overhead. When control overhead is increased, the bandwidth required to transfer all those control overhead, that increases, and that actually reduces the bandwidth for data transfer. Actually that wastes some more network energy or node energy also. Okay, so the updates due to the broken links or new links leads to very heavy control overhead during high mobility. So more is the mobility, more number of control overhead, control packets are generated, more control overhead, more bandwidth wastage will happen. So more is the mobility, it is very bad for any network topology, for proper topology maintenance. A small network with high mobility or a large network with low mobility can completely choke the available bandwidth. So during mobility there is huge amount of extra packets generated because again the RTS CTS data acknowledgement has to be retransmitted. So let it be a small network with high mobility or big network with small mobility, so any amount of mobility might create some kind of congestion within the network. Excessive control overhead is proportional to the number of nodes. So more is the number of node, more is the permutation combination between source and destination, then more number of RTS CTS packets will be exchanged. So hence this protocol is not suitable for ad hoc wireless network which have limited bandwidth and whose topologies are highly dynamic. So if there is too much of mobility, node mobility possible in the network, if you are allowing the network with heavy mobility, and if some network is having less bandwidth, so both the things are very difficult for a network. So huge mobility is one problem, and less bandwidth is another problem. So if there is one network with huge mobility and less bandwidth, there this DSDV protocol cannot be applied because continuously the table has to be updated, continuously the updated information has to be exchanged between different nodes. So with less bandwidth, it is not possible. Okay, so where can you apply DSDV protocol? At least mobility should be not very high. Okay, and bandwidth allocation for all the nodes should be considerably high. Okay, so these two things are there. So what should be high for DSDV? Bandwidth should be high, mobility should be less. So for any network, if bandwidth is less and mobility is high, there this kind of protocol cannot be applied. So last point, in DSDV, to obtain information about a particular destination node, a node has to wait for a table update message initiated by the same destination node. So this delay could result in stale routing information at node. So when there is an information exchange, at that time the information update, that process takes some minimum time. It doesn't happen very fast. If the node mobility is very high, if the bandwidth is very less, in that case that update will take further some more time. Okay, so it takes quite a lot of time to update the information. So in between the information is getting updated, if the source node wants to set up some linkage with the destination, at that time with the wrong information it will update the mechanism. So if there is a huge time taken for the table updation, so that huge time taken by the table updation will hamper the network performance. So table updation has to happen very fast. Okay, so when node mobility is more, table updation cannot happen very fast. Okay, so that is another problem of the DSDV protocol. So if the question is asked in the exam that what is the DSDV protocol, so you have to draw this thing, you have to draw one network, this topology you have to draw, and for one source and one destination you have to explain with the first three columns. Fourth column, any values you can write, that is just a root number, that is not a big thing, but first three thing is technically you have to understand. So only DSDV is asked, topology and table you have to write very clearly, and DSDV with route maintenance, in that case you should write less. In that case you have to explain what happens when node mobility happens. So this diagram is very important. Rather, this diagram will do. Okay, so this diagram, so whenever initially this was the thing, what was the route table, and after the node moved, now what is the new topology and how much is the change in the route table, this thing you have to explain very clearly. Okay, so this actually there are two questions. One is what is DSDV, explain DSDV with the table, and second one is route maintenance in DSDV with table. So these two are the different questions, and with this advantage and limitations also will be asked. So be careful to explain all these things properly. So there are 3 advantages and 4 limitations that has been explained so far. Let us see now next type. So this is another type of classification what we have seen. It is called hierarchical state routing protocol. So whenever the nodes are there, depending on its position within the topology, there is a hierarchy which is created, that some nodes are very important, some nodes are medium important, some nodes are less important. So the use of hierarchy during routing has several advantages. The most important one being reduction of the size of the routing tables and better scalability. See, biggest problem in DSDV routing is huge amount of huge size of table. Okay, so this size of the table is very big. This is the best or worst problem in case of DSDV. So what we are doing in hierarchical kind of a thing, we are going to reduce the size of the routing table. So this is the first thing. So hierarchical state routing, or short HSR, is a distributed multi-level hierarchical routing protocol that employs clustering. That means few nodes are taken together and they are given some importance level, that we will see in Fisheye routing protocol. Okay, so nodes are actually clustered at different levels with efficient membership management at every level of clustering. So clustering means few nodes together, they are classified as a class. Okay, so the sender node and near about nodes, they will be one class 1. Okay, the nodes which are 2 hop distance, they will be class 2. Nodes which are 3 hop distance, they are class 3. Likewise, classifying the different sensors or clustering the different sensors, it makes the routing protocol little easy. The use of clustering enhances resource allocation and management. For example, the allocation of different frequencies or spreading codes to different clusters can improve overall spectrum reuse. Okay. HSR operates by classifying different levels of cluster. Elected leaders or cluster heads, so cluster head is CH, at every level act as a member of the immediate higher level. Different clustering algorithms are employed for electing leaders at every level. So we'll be seeing clustering in detail towards the mid part of this chapter. So clustering means nothing but take few nearby node together and form a region and give that region an importance level and a name. Okay, if you're doing that, it is easier to control the whole network. Like there are 60 students in the class, I have to know every student separately, so that is difficult. So what I do is I make 5 groups. If there are 50 students, I make 5 groups of 10 students each. So each group, then I allot a monitor. Okay, so each group is having a group member. So that is actually the cluster head. So in that case, if I can control the 5 cluster heads, I can control 50 students. So there is the same concept used here in case of networking also. So HSR operates by classifying different levels of cluster. That means whole number of nodes are divided into 4 or 5 different groups, importance level, and from each group we are electing a cluster head. So just by controlling the cluster head, we can control the clusters, we can control all nodes. In addition to the physical clustering, a logical clustering scheme also exists for HSR. This logical scheme is based on certain relationship among nodes rather than the geographic position, as in the case of physical clustering. So let us see what is called as Fisheye routing state protocol. So this is one type of hierarchical state routing protocol. So this is also a table-driven routing protocol. It generates routing overhead at the same time. On-demand routing protocol generates routing overhead proportional to the number of connections present in the system, network size, and node mobility. Same thing was explained in case of DSDV, that if number of nodes are more, mobility is more, routing overhead will be more. But what is fisheye? Zone routing protocol. So this is very important. So depending on the position of the nodes, the whole network is divided in some kind of zone. I will show you the diagram, you'll understand. So this is a zone routing protocol, which uses intra-zone proactive approach and inter-zone reactive approach. So within the zone, all the informations are exchanged very vigorously. Okay, outside the zone, information is not much exchanged. So if you're within our group, if you're within our cluster, all informations within the cluster is exchanged full. Okay, but if some node is outside the cluster, with that node, much information is not exchanged. So this is called inter-zone reactive and outer zone. This is called as interzone proactive. That means within the zone, all the information is exchanged, and interzone reactive. So intrazone is within the zone, interzone is outside the zone. So interzone, it will react. It will not be so open to exchange information. The fisheye state routing protocol is a generalization of get switched routing protocol. So these are only names, not very important thing. For your theory, you can write that. FSR protocol reduces information required to present the graphical data. It reduces the routing overhead. It reduces the routing table size. So what is fisheye? The basic principle behind the technique is the property of fisheye. What is the fisheye principle? Here the information is captured with greater accuracy near the center of the topology. So what is the center of the topology? Wherever there is the sender, main sender is considered to be the center of the topology. So towards the center, huge amount of information is collected. All the information are very important, and all the information are exchanged among the center of the topology very vigorously. As we are going outside the center, as we are going far from the sender or center, amount of information exchange become less and less. So this is what is said. Basic principle behind this technique is the property of fisheye. Okay. Here the information is captured with greater accuracy near the center of the topology, and the accuracy decreases as moved toward the periphery from the center point. Periphery means towards the circumference. This property is translated to routing ad hoc wireless network by a node. It keeps the accurate information about nodes which are in its local topology, so towards the topology center. So towards the topology center, whatever nodes are there, all their informations are accurately captured. This accuracy of information for nodes far from topology center decreases with increasing distance. So as the nodes which are far from the sender, their information is not much captured or not exchanged much. Here is what is fisheye topology, FSR. Okay, fisheye state routing protocol. So just see what is it. So here is the sender node, node number 5. Here is the receiver node, node number 13. What we are finding is, where is the fisheye? So this is the red circle. This is the center of the whole topology. It is said that one hop scope. What is meant by one hop? 5 to 6, 5 to 10, 5 to 4, 5 to 2. All these things are one hop distance. Whereas from 5 to 3, it is 2 hop distance. Okay. So this 10, 4, 2, 1, 6, 5, they are one cluster. They are the closest cluster. This is called one hop scope, one hop cluster. This is the most important region of this whole network. So all information of this central area is exchanged more frequently, and this is the most important information for the topology. Whereas if you just check this green circle means node 11, 14, 12, 8, 7, 3. So they are actually 2 hop distance from 5 to 14. How many hops? 5 to 10, 10 to 14. 5 to 11, how many hops? 5 to 10, 10 to 11. 5 to 12, how many hops? 5 to 10, 10 to 12. So these are 2 hop distance. So this is called region of 2 hop scope captured into at this area exchanged less frequently. So this green area nodes, that means information of node 3, 7, 8, 12, 14 and 11, they are exchanged or updated less frequently. What is the third hop nodes? Just check. 15, 13, 9. They are outside the second hop range. So they are in the third hop range. So their information is not much exchanged. So this third region or region of 3 hop scope, least info exchange. So what is the most important cluster? That is 6, 10, 4, 2, 1, 5. This is called fisheye because this is there at the center of the whole topology. Away from the fisheye, that is called 2 hop, that is 11, 14, 12, 8, 7 and 3. So information exchange of say 3, 7, 8, 12, 14 and 11 is less. Updation information is less. And list information exchange, list information updation happens for nodes which are very far from the fisheye. So fisheye is 5. Fisheye is the center of the topology. So 15, 13, 9 information is updated very less. They are exchanged information very less. Okay. So from this diagram, you have to understand what is meant by fisheye topology. That is, red circle is the most important circle. Everything is happening inside that is captured, exchanged, updated. Thing from red to green, they are medium important. So their updation rate is medium. Their information exchange rate is medium. Minimum information update and minimum information exchange happens for greater than 2 hop distance, that is 15, 13 and 9 informations are exchanged least and they are updated also least. Take this example, because this is a network topology, new network topology, so there are only 4 nodes and what is meant by fisheye. So just check and you can take, so there are 4 tables given, just take 4. Okay, so 4 is now the main point. So 4 is now the center. Okay, if 4 is center, if 1 is the destination, so check this table. So this is topology at node 4. Okay, now 4 is the sender and it wants to send the information to 1. So 4 is at the center. Okay, that's why from 4, what are the neighbor nodes? So neighbor nodes of 4 is 3 and 1. So this table I'll explain, remaining you can understand. So from 4 destination, so from 4, node 4 is the center. If destination is also 4, that means sender and destination is same. How many hop count? 0. So if 4 is the sender, 4 is the destination, that means there is no information is not going anywhere, that means this is 0 hop. But from 4, if it's going to 1, so for 1, which are the neighbors? For 1, which are the neighbors is 4 and 3. So whenever I am saying destination 1, which are the neighbors? 3 and 4. So everywhere you will find neighbor of 1 is 3 and 4. Everywhere you will find neighbor of 1 is 3 and 4. Everywhere neighbor of 1 is 3 and 4. What are the neighbor of 4? Neighbor of 4 is 3 and 1. So just check here. Neighbor of 4 is 3 and 1. Neighbor of 4 is 3 and 1. Neighbor of 4 is 3 and 1. Likewise. What is the neighbor of 3? Neighbor of 4 is 1, 4 and 2. So neighbor means 1 hop distance. Whichever nodes are there, that is called as neighbor. Who is the neighbor of 2? So whenever I am talking about 2, who is the neighbor of 2? Neighbor of 2 is only 3. Okay, now just check, if 4 is the sender, then 1 is the receiver. Then who are the neighbors of 1 is 3 and 4. And between 4 and 1, how many hops? There is only 1 hop. So whenever 4 is there, 3 and 1, so this is falling within the fisheye. Okay, so this is the 1 hop destination. So all the information related to 4, 3, 1 will be captured properly. But if you check 2, 2 is the destination. So 4 is the sender node and 2 is the destination node. So 2 is 2 hop away. So from 4 to 3 is 1 hop, 3 to 2 is another hop. So 2 node, if this is the destination and 4 is the source, then 2 is 2 hop away from 4. That means this red dotted line below to it, whatever information is there, that is exchanged less. So this 2, 3, 2 information will be exchanged and updated less. Whereas all the information related to 4, 3 and 1, 4, 3 and 1, they will be exchanged more. That's why it is saying that topology information at 4. Let's check topology information at 2. So now 2 is the sender node. Okay. And who is the receiver node? If destination is 2. Who is the neighbor of 2? It is 3. So this table is destination 2, neighbor is 3, and 2 is the source, 2 is the destination. How many hop length? 0. But if 2 is the source and 3 is the destination, so who are the neighbors of 3? Neighbors of 3 are 1, 2, 4. So the same thing, just beside 3, everywhere you will find beside 3 it is 1, 2, 4. Beside 3 it is 1, 2, 4. Beside 3 it is 1, 2, 4. Same information. But from 2 to 3, how many hops now? 2 to 3, there is only 1 hop. So that's why this, if 2 is the sender, then 2 and 3 is forming the fisheye. 2 and 3, they are forming the 1 hop circle. But 2 to 4, there are 2 hops. Just check. If 2 is the source, this is table for 2 source. 4 is the second hop. So how many distance? 2 hops. So 2 hops means this is in the second important loop. So from 2 to 4, it is 2 hop distance. From 2 to 1 also it is 2 hop distance. So 2 to 3 is 1 hop, 3 to 1 is 1 hop. So from 2 to 1, if 1 is the destination, it is 2 hop distance. So that's why below red line means this is the further, or this is not at the fisheye. So if 2 is the source, who are at the fisheye? 2 and 3 are at the fisheye. And 1 and 4 are the away from fisheye. So below to red line, it is less important. Above red line, it is more important. Here, everything is within 1 hop distance. If 3 is the center node, sender node, 4 is 1 hop distance, 1 is 1 hop distance, 2 is 1 hop distance. So when 3 is the sender node, all the 3 other nodes, that is 4 to 1, everything is within 1 hop distance. So this is the ideal scenario. 3 is the sender, every other node is within 1 hop distance. So all this node information for 1, 4, 2, everything will be captured and updated very frequently. So this is the best table. This is the most busy table. This is the best table. That is 3 is the sender node and 4 can be the receiver node, 1 can be the receiver node, 2 can be the receiver node. Just check, there is no 2 hop. There is every time this is 1 hop distance. Okay, so this is the best table because 3 as a sender is the best position. So 3 is exactly there at the eye of the fish. So 3 is the best positioned sender node for this 4 node topology which is shown here. So this is, you have to explain with this example, and all these tables you have to understand. Only the third column changes. Okay, depending on the source and destination position, only the third column changes. First and second column remains the same. Okay. So the example is given. This example is actually giving the network topology information maintained at nodes in a network. This line is very important. Second line, that routing information of 1 hop distance nodes from the center are exchanged more frequent than routing information of nodes that are more than 1 hop distance. That means whenever 4 is the sender node, take this table, information of 1 and 3, so 4 to 1, 4 to 3, they are exchanged very frequently, but 4 to 2 information which is below this red line is not exchanged more frequently. So this is what is said. Routing information of 1 hop distance nodes from the center are exchanged more frequently than routing information of nodes that are more than 1 hop distance. So 2 hop information are not exchanged more frequently. Last thing, information about nodes that are more than 1 hop away from the center node are listed below the dotted line of the topology table. So for node 4, when this is the sender, 2 is the receiver, so 2 is 2 hop distance. So that's why 2 is below the red line. That is what is said here. That is, nodes which are double or more than 2 hop distance or more than 1 hop distance are listed below the dotted line in the topology. That means they are less important. So this is a lot of information about the Fisheye state routing protocol. If you understand these things, you just go through. And I think this is the last slide. It says that the link state information for the nodes belonging to 1 hop scope, that means within the center, is exchanged at highest frequency. That means more frequently it is exchanged. Frequency of exchange. Frequency does not mean hertz. Frequency means number of times the information is exchanged. That is high. Frequency of exchanges decreases with an increase in the number of hop scope. That means 2 hop is exchanged less, 3 hop is exchanged least. Thus, immediate neighborhood topology information is maintained at node more precise compared to the information about nodes further from it. So, this 5 lines are explaining everything about Fisheye routing protocol. So, 1 hop scope information exchange is too high, 2 hop scope information exchange is medium, and more than 2 hop information exchange is very less. Message size of a typical topology information update packet is thus significantly reduced by removing the topology information from far away nodes. So just check the size of the table in case of Fisheye table. And just remember the size of the table in case of DSDV. So tables in case of DSDV was huge, but tables in case of Fisheye are quite less. The path information for a distant node, that means which is far off, may be inaccurate as there can be staleness in the information because updation does not happen very fast. So stale information means it is not updated information. Okay, so distant node route information may be stale, not updated fast, but this is compensated by the fact that the route gets more and more accurate as the packet nears its destination. So when the packet keeps on going to the destination which is far away, that path information is updated quite frequently. So FSR, that is the Fisheye state routing protocol, scales well for large ad hoc network because of the reduction in resolving a routing overhead due to the use of discrete mechanism where varying frequencies of update are used. So that means even if the whole network topology is of big size, but then also the routing table will be very small. At least it will be less compared to the DSDV. Finally, what are the advantages of Fisheye routing protocol? Multi-level scopes of FSR significantly reduces the bandwidth consumed by the link update packets. So in this case, we'll be finding that less amount of control packets, less amount of RTS, CTS and acknowledgement packet are being exchanged, even if mobility in the network is very high. So amount of control packet exchange will be less. If control packet exchange is less, bandwidth usage unnecessarily, that also will reduce. So multi-level scopes of FSR significantly reduces the bandwidth consumed by the link state update packet. Link state update packet is nothing but control overheads. Hence, FSR is suitable for large and highly mobile network. So even if the network is very large, many number of nodes, 4 hop, 5 hop, then also FSR, that is Fisheye state routing protocol, will produce lower size table and they will be very effective. Choice of hop count associated with each scope level has high impact on performance of the protocol at different mobility and hence must be carefully chosen. So how many hop count is to be taken from source to the destination, or what should be the hop size, or how many hops you will consider as within the cluster. So here one hop has been considered within one cluster, not necessarily that one hop. Sometimes I may take bigger cluster. Okay, so 2 hop also I can define as the center cluster. So that is what it is saying. Choice of hop count associated with each scope level. So here one hop is one scope. Sometimes if the network is very big, you can define 2 hop as one centered cluster. Okay, so hop count actually increases the, or more hop count increases the network overhead, less hop count decreases the network overhead, but bigger area of every scope, bigger area of cluster, in that case the accuracy will be less. So choice of hop count associated with each scope level has high impact on performance of the protocol at different mobility and hence must be carefully chosen. But to tell everything, that Fisheye state routing protocol can work very well even if there is high mobility. So that's all for today's lecture, what all we have done. So initially we have seen the classification of routing protocol. Then we have seen DSDV, that is the most primitive or first type of routing protocol, which was mainly designed for wired routing, but the same concept is taken to the ad hoc routing. There we have seen that tables are continuously updated and updated table information is flooded among all the sender nodes, all the sensor nodes, so that every node can come to know about the update or update information about the network. And lastly, we have seen Fisheye state routing protocol. So one very big limitation of DSDV was the table of routing protocol was very big. So if you want to reduce that, what you have to do is you have to take the help of clustering. So in clustering, what we are doing is not one node, but one hop node, one scope node. We are clustering together and we are taking the cluster which is closer to the sender node as the center of the whole topology, and we are exchanging information more within the center of the topology, and as we are going outer side, that is inter scope, we are exchanging less amount of information, and this actually is helping us reduce the table size of the whole protocol. So this is the advantages of Fisheye state routing protocol. If asked in the exam, you have to draw the protocol diagram, you have to take this example of 4 nodes, 4 hops, and you have to write all these 4 tables, and with respect to that you have to explain these 3 points, what exactly is the advantages of Fisheye routing protocol, and finally the what is the protocol and what are the advantages of FSR. That's all. I stop now. If there's any doubt, please let me know. And today evening I'll be posting the OBA, and please write the OBA and submit by tonight in PDF format in my email ID. Thank you.